This is the Pearson Edexcel IGCSE Further Pure Maths Paper 2 from June 2021. Alright, starts off very easy. Take away 5x from both sides, add 7 to both sides, divide by 3, we get this. Here we can factorize this to make this, I believe. And now we're looking for, obviously, critical values of -1/2 and 3, and we're going to be bigger than 0. If you need to be bigger, that means you need to be either side of the two critical values, so it's the left of the smaller one and right of the big one. So we need to be less than -1/2 or greater than 3. There's lots of ways to justify that. You can draw a graph, you can do a little number line and test what happens either side of the critical points, which are 3 and -1/2. But in any case, you get this. And then we want to satisfy both of these things. So of course, being greater than 3 and being less than 4 at the same time is fine, but also being less than a half, or -1/2, sorry, is fine, because that's also less than 4. So we end up with these two conditions here to finish up. All right, here. Now, you could actually work with this, but I decided to do this the cheat way, which is just to work with this here. So let's just expand this out and simplify. So expand it all out and simplify lots of things together. We get this. And now we can just compare coefficients from what we've got to what we've got here. So I think B needs to equal a 25th, just looking at this very, very quickly. If B is a 25th, then we can replace it here, and that means -2/25C is 4/5, and of course we can times by 25 divided by 2 and get C is -10. And then we can finally look at this object here and say all of this stuff needs to equal 2. Yeah, but of course C is 10 squared, -10 squared is the same thing, of course. And you get A as this, and therefore we can write it out like this. So you don't even need to deal with this. You can just deal with the thing they give you, and then just set the coefficients equal to each other. It's just quite a nice way of doing it sometimes. Hence write down the max value of f of x. So if x is, well, this is minus something squared. So here's 6 minus some stuff squared. Now, whatever you do with this, when you square it, it's going to be positive, and so it's going to be 6 minus something. So the only way to avoid that is to make this whole thing 0, and then the biggest value of f of x you can get is 6. And of course, to make this 0, you need to make x 10, and then you get 6 minus 0, and then, cool, yeah, so we're done. 3 here, so the arc length of a sector in radians is just r theta, so this is just 18 times 2 pi over 3, which is that. Here, there's lots of ways to do this. Firstly, they want this angle here, which is just 2 pi, because that's how many radians are in a quadrilateral. So 2 pi minus pi over 2 minus pi over 2 minus 2 pi over 3 is pi over 3. So that's this angle here. It doesn't look like it at all. Why doesn't it look like it at all? It's just because the picture's terrible, I guess. I'm going to hope that I haven't got that wrong, and whatever. I just noticed the picture just looks terrible, but I think it's probably fine. Anyway, I didn't end up using that. I think I probably should have used this, but I didn't end up using it. I just cut the thing in half and said this is a right angle, so I can just use SOHCAHTOA here and say this angle here is pi over 3 because it's just half of 2 pi over 3. It's going to be a symmetrical picture. So therefore, tan of this angle is this over this. If I call this obviously just PT, tan of pi over 3 is PT over 18 times by 18. Tan of pi over 3 is root 3. We get this. Therefore, the area of this triangle is a half times 18 times 18 root 3. Just half times base times height, right angle between them. Double that to get the area of the entire quadrilateral, and we get this. And then, of course, the area of the sector is just r squared theta over 2, where r is 18, theta is 2 pi over 3, and we get this. And of course, if we take away the two results, we get to 3 significant figures, we get this thing here, and that'll be our answer. Question 3, you may as well draw a picture to do this because you're going to need one eventually. So there's the two coordinates. The gradient between them is clearly going to be, well, it's 7 across and it's 21 up, so the gradient is 3. Now we can just use y minus y1 equals mx minus x1, as long as you just use the same x1 and y1 coordinate pair in here. We get this. You could have just left it as this because it just says an equation. But anyway, AP P to PB is 3 to 4, so P is like here somewhere, 3 parts, 4 parts. That's 7 parts in total. So each part is going to be a 7th of this and a 7th of that, so that's going to be 1 across 3 up. And then times it by 3 to get 9 across 3 right. And then go do that system from here. So 3 right gets you to -1, and 9 up also gets you to -1, and that'll be our coordinates of P. Q is at MN, which goes through P, such that it's perpendicular to this line, so it must be somewhere like this, and makes a right angle like this. This distance is apparently root 10. And of course, if it makes a right angle, that means this gradient is -1/3, because this gradient was 3. So okay. Let's do some stuff here. So this is the distance bit first. So we've got the easy bit is n plus 1, right? So this distance here is n plus 1 because it's just n down to the x-axis and then plus another 1. So that distance is n plus 1. This distance here, you can just always use the system of x2 minus x1. Of course, this is m minus minus 1, and that will get you the total distance across here. So it's just essentially y2 minus y1 and then x2 minus x1. It's always a system that would work. It's just more easy to visualize like with this one. So I could have written minus minus, but it doesn't really matter. Of course, this is going to be a plus anyway. The other one, just the same. So for the gradient, it's going to be equal to minus a third, right? Because this is gradient 3, so this is gradient minus a third, because they're perpendicular. And we're going to have the y2 minus y1 over x2 minus x1, which again will give us this kind of thing. I could have put minus minus here, but it doesn't really matter. This is n plus 1. You can cross multiply, or you can just leave the minus a third here, apparently, and then replace all of that into here, because that's n plus 1 matches here. A third squared is a ninth, and then you just square this out, and you just have a ninth in front of everything. And then I think I times everything by 9 here, and then finally collected everything together, factorized for this result here. And then, of course, that means m is either minus 4 or 2, but m is negative, so that means m is minus 4. And then that means n, so minus 4 plus 1 is minus 3, times minus a third is positive 1, isn't it? So 0 plus 1 is 1, so that means 0 here. R is coordinates minus 11, minus 21, so that's way over here somewhere. I redid the picture a little bit, but it's over here somewhere. Show A, B, and RQ are equal in length. Well, this is A and this is B, remember. So that was 7 across and 21 up. We had it on the previous picture, didn't we? 7 across, 21 up. But in any case, that's going to be AB, therefore, is just root 7 squared plus 21 squared, which is this. And then this coordinate here, this is R, and that needs to go to Q, which was this one here. Well, that's, again, just 7 across, 21 up, which is nice, because that means, of course, it's the same length. And also that they're parallel. Well, clearly this is gradient 3. It's 21 over 7, which is gradient 3, which is what we already decided this one was based on this here. So maybe just explain that, and therefore you end up with that. We've got the area of the quadrilateral A, which is here, B, Q, R. Now that's just clearly a parallelogram. So the area of parallelogram is just the base times perpendicular height. But we already know the perpendicular height is root 10, because we worked that out much earlier, or in fact we were actually told that much earlier. And the base is just that 7 root 10 that we just found. So the area of the parallelogram is just 7 root 10 times root 10, which is just 70. And we'll have our answer. Question 5 then, kind of interesting. So a geometric series would go A as the first term, then AR, because you times it by R, then AR squared, because you times by R again, and so on. So the second term plus the fourth term is this plus this equals that. And the third term plus the fourth term is this plus, sorry, is this plus this? No, it's not. It's this. Sorry, is that the third and the fourth? Which is, sorry, the third and fourth, here and here. Yeah, I don't need this one at all. Okay, I've got this right, good. So there's a few ways of doing this, kind of interesting. I decided to factorize as much as possible here, and likewise here. And then when you divide this by this, the AR will cancel, and you'll just be left with 1R on the outside with this, and then this on the bottom. And this divided by this is just this, according to my calculator. Cross multiply. Of course, we've got rid of the A's now, so I can just solve this. And it factorizes just about, and we get answers of a quarter and minus 5/3. Of course, if the series is convergent, that means that the modulus of R is less than 1, which means this is the correct answer, so that can't be there, and it'll be this instead. So we can use this to find A, right? If we just substitute into this result, just do some calculator stuff, times by 4, and then divide by this thing here. We get this, and then this sum to infinity, given in the formula book, is A over 1 minus R. A is this, and R is the quarter, so you just type that into a calculator and you get this here. Question 6 then, given x minus 3 is a factor, that means f of 3 is 0. So let's put in 3 into these x's and set it equal to 0, and we get this. Do some simplifying, and you get this. Do some more simplifying, you get that, which is good. That's 3 marks. Given x plus p is a factor, that means f of minus p, because remember you swap that sign there, f of minus p is 0. Put that in there as well, so every time we see an x, we're going to replace it with a minus p. Now I actually didn't do that there, but that's because minus p squared is the same as p squared, so that doesn't matter. I literally just couldn't be bothered to type one single negative sign because I'm that lazy. We, of course, expand that out. These two things cancel. We end up with what they wanted as well. So now we just need to solve these two simultaneous equations. I decided the easiest way to do that was just do this one minus this one, because the q's will just instantly cancel. We'll end up with this. We tidy it up. Now this factorizes. So p is either 2 or minus 3, but I think you're told p is greater than 0. So therefore p is 2. And therefore q, 2 squared is 4 plus 20 is 24. That means q is minus 24. And we'll have that done. Using these two values, factorize f of x. So putting those two values into there, we end up with this as the equation. We know x minus 3 is a factor. We know x plus 2 is a factor. So we can just write those out. What's the last factor here? Well, clearly this term needs to be an x, because x times x times x is x cubed. And clearly this needs to be a plus 4, because minus 3 times 2 is minus 6. times plus 4 is minus 24, and we're done here, and that's factorized. Good. Question 7, just type this into a calculator with each of these values. You get these three things here. Then you just plot the coordinates with x's. This is not difficult. You then put a curve through them, which is easier on paper than it is in PowerPoint. Now this one here, when you're doing this kind of question, what you want to do is do anything in your power, by all means necessary, to turn this algebra here into something that contains this algebra here. So what I'm going to do is I'm going to add x to both sides, and I'm also going to bring the 4 down to the front. And that does two things for me. It means if I divide by 4, I'll get the x over 4, which is what I have here. And then, of course, if I raise both sides to the power, 3 to the power both sides, it'll cancel out that log, and I'll be left with 3 to the power x over 4 over here, which is good. If I add 2 to both sides, I'll get this. And now what I've said here is that essentially this question here, solving for x here, is equivalent to solving for x here, because I've just done some algebra. But solving for x here is equivalent to asking, when does this curve here intersect this line here? So to find that out, we're just going to draw this line. When x is 1, we have 6. So it goes through 6. When x is 2, we have 4. So it goes through 4, and we get this line here. And the solution looks like it's roughly 2.1, and we'll have our answer. Good. That question comes up in every single paper, so probably should be good at it. This is a really interesting question here. As soon as you logs of different bases, you need to use the Taylor-Swift law for change of bases, which is that log to base a of b is log to base whatever you want. Of course, we all want Taylor-Swift of this one b over log to base whatever you want this one a. We're going to use that, but first I'm going to think about this one here. So let's just turn everything into base 2. So this is 2 to the 4 to the 4, because 2 to the 4 is 16. And this is 2 to the 2 to the b squared. 2 times b squared is 2b squared. 4 times 4 is 16, so we end up with this. And then, of course, same base means you just take away the powers. So I think a must be equivalent to 16 minus 2b squared. And that looks like that one's simplified quite a bit, so I'm just going to leave that there and mark on this one. Of course, the change of base law is going to come in handy. Going to move the 3 up to the top first. Then I'm going to change base. So I'm going to say this here is log to base whatever I want. I'm going to choose 4 just so it matches this one. So log to base 4 of b cubed over log to base 4 of 8. Log to base 4 of 8, you can type in a calculator, but it's clearly just 3 over 2 because 4 to the power 3 over 2 is 8. Square root and then cubed, you get 8, so that's good. Dividing by 3 over 2 is the same as times by 2/3. This 3 can come back down here now, cancel with this 3 and just end up with 2 lots of this. But then, of course, this 2 can bounce up to the top. And now finally, same base here means that this can just go together. So we get log to base 4 of ab squared is this. Do 4 to the power both sides. It cancels out the log. 4 to the power 5 over 2. Well, the square root of 4 is 2 to the 5 is 32, so we end up with this. And finally, we have 2 nice simultaneous equations to work with. I'm going to times this one by b. No, I'm not. I'm going to times it by a. Because then I notice ab squared, it just appears here, so this can be replaced with a 32. So we get this equals this minus 64, because you times it by 2. Move everything to one side, factorize a, and a is clearly 8. 32 divided by 8 is 4. B squared is 4, means b is plus or minus 2. And just to explain this, that I couldn't be bothered because I couldn't be bothered to write it down, but you can't use minus 2 because you can't put a negative in this log here. So b is 2 will be the only answer, and just maybe explain that. Good. So cross-section area of this thing here, well, it's equilateral, so this is x and this is x. So half AB sine C means the area of this triangle is a half times x times sine 60. Of course, the angle is 60 because it's equilateral, or pi over 3, or whatever, it doesn't matter. Root 3 over 2, so this is root 3 over 4x squared. Good, I'll just call that area for short. And now it wants us to find dx by dt. So let's do some messing around with the chain rule. Dx by dt is I think going to be dx by dA times dA by dt, because these two things can sort of cancel, and we'll be left with this. Now dA by dt, the rate at which the area is increasing, well, that's dA by dt, right, is 0.03. So I can say that thing needs to go in here. Dx by dA, well, dA by dx is just differentiating this. So bring the 2 down, lower this down, you get 2x root 3 over 4, which is just x root 3 over 2. Flip that over, and you'll get dx by dA. So therefore, dx by dt is just this flipped over times 0.03. And they want me to evaluate that at x equals 2. So put x equals 2 in, these cancel. You just get it 0.03 over root 3, which is this here. And now it wants the rate of increase, which is dv by dt of the volume. So dv by dt is what it wants next. Now we can set up some chain rule. dv by dt, again, is going to be dv by dA times dA by dt. And that seems useful because we're being told dA by dt. The problem is this dv by dA business, because, okay, so the volume is cross-section area times length. So that's going to be this times 4x. But the thing is, that's far easier to get in terms of x than it is in terms of a. Like I could replace these a's with this a here with these x's and get v in terms of x. But that wouldn't be helpful if I wanted to differentiate in terms of a. So actually, I'm going to not use this. I'm going to change that to be this here and just use x's instead. And now I'm losing this, which is a shame because I have that. But I do have this anyway because I worked it out in the previous bit. So that's no problem. So okay, replace this a with this thing here. You end up with this because the 4's cancel and then the x's just become an x cubed. Differentiate it to get dv by dx is this here. You can put that result into there. You can put this result into here. And then you can evaluate it at x equals 2, which I guess you need to do before you put that into there because this is only true at x equals 2. But in any case, at x equals 2, this thing is equal to that, as we discussed, and you get error carried forward. You forgot that wrong, so I'm not too worried about this. And then x equals 2, put it in there, and you get this. And you type that in, and you get this here. And it's nice that this is exactly 0.36, because it hasn't told you to round at all, so you know you've probably got this whole question right if you got there. Good, so, okay, we'll just tan inverse minus 3, we get this. Tan is repetitive every 180. It's the easy one that's just, you just always add 180. You'll never miss another solution or anything. Just add 180 a couple of times and then round to the nearest whole number and we'll get these here. That's 3 very nice marks. This question is actually kind of tough for 3 marks for sure. There's a couple of really nice ways of doing it. What I decided to do was I said that let's just divide everything here. I moved the 6 over first, divide everything by cos, and then divide everything by cos again. And now this is tan squared. This is tan. So that's cool. What about this over here, though? Well, sine squared plus cos squared is 1. Now, I kind of figured this out because I just know the rule that between sec squared and tan squared. I realize maybe that's not in the spec here, so this is hard to spot if you don't know that. But because I knew I was looking for it, that made it easier for me to think to do this. Obviously, if we divide everything here by cos squared, this turns into a 1. This turns into a tan squared, and this turns, well, I'll just leave it as this because I don't think sec squared is in this spec, so I'll just leave it like this. But this is clearly 6 times 1 over cos squared, right? So I can just replace that with this stuff here. So I can say this is all this minus 6 times this thing here. And again, it's easy for me to come to this because I sort of know what I'm doing, and I know some stuff beyond the spec. So this was the natural way for me to do it. Anyway, you end up with this here. The other way of doing it, the way the mark scheme suggests, is a really nice trick is every time you see a 1, if you really don't know what to do to get from here to here, if you see a 1 anywhere in here, just replace that with a sine squared plus cos squared, because that is in your spec. Now this is a 6 times 1. So you replace that 1 there with this here, and if you do that, and then you divide by cos a couple of times, you end up just getting straight to here. But anyway, that's kind of cool. So nice trick to remember if you to do that. Anyway, replace all of this with this, obviously, because this question is equivalent to this question with y's in there. I should have used y's. Apologies, just replace these with y's. It doesn't really matter. Just in your head, replace these two things with y. Again, it really doesn't matter at all. Anyway, you factorize this out. You've already solved this equation because you get tan theta is minus 3 or tan y is minus 3 really, but again, it doesn't matter. And of course, you already solved that. You get these two solutions here. This one here, just do tan inverse and then add 180. Only once, because if we add it again, we'll go past this. And we get to the nearest whole number, those two solutions there. And we'll be done with this question, which is nice. Now, the last one is about rotating this area around the x-axis like this. The easiest way, or the first thing we need to do is maybe find this coordinate here. So let's just set this equal to this, times by e to the x to make this go away. Now, of course, take a log of both sides, and then divide by 2, except we can bring this half up to here. 4 to the power half is the square root of 4, so that's 2. So we just get this, and so this coordinate here, or this point here, is log 2. So to find the total volume when you revolve this round, we're going to integrate this curve between 0 and log 2. But of course, it's pi integral of y squared, isn't it? To do that, so it's going to be pi times that, between those two things, times this into e to the x all squared, which is of course e to the 2x. And then of course we're also going to integrate between log 2 and a of this one here squared as well. So this makes 16 e to the minus 2x when you square that out. And we're told that r is equal to this, which doesn't seem very helpful right away, but I'm just going to leave it there. Of course, integrate this for a half e to the 2x and integrate this for minus 8 e to the minus 2x, because the minus 2 times that would be plus 16. Put in the two limits. Now be super careful when you do this. For a few reasons. We need to bring this 2 up to here before we cancel the e in the log. So this 2 needs to be brought up to here. Likewise over here, except we also need to bring this minus up to there. So this needs to be e to the log 2 to the power minus 2, which is, or 2 to the power minus 2 is a quarter, right? Because you flip it over and square it. So that's all cool. E to the power 0 is 1, obviously, so we end up just with a half here. Not going to really do too much with this. Obviously, these terms can become a positive. Now, okay, what else do we do? Well, now we can cancel this e and this log, and this e and this log to just end up with 8 times a quarter is 2 here, and just a half times 4 is also 2 there. So we're here, so let's keep going. 2 minus a half is 3 halves, I guess. And now we can maybe expand out this pi as well. And 2 pi plus 3 over 2 pi is 7 over 2 pi. And we just get left with this. Now, what to do here? Well, one way to solve this for sure would just be to make a equal to 2, to make these two things match, and therefore then make k equal to 7 pi over 2. And that would be one way of doing it. It's a possible value that does it, and a corresponding k value would be that. And we're done here, and that's the whole paper. Thanks for watching.